Hello YouTube, I'm ABC, and today I'm making a tutorial for you guys. This is part 2 of my recursion series. Last series we talked about basic uses of recursion, and today we're going to talk about some more applications of it. Because you might have noticed that the way we talked about yesterday, or the previous tutorial, there's nothing really special using recursion. You could just as well use loops in order to do the same thing, because you're basically doing this process over and over again. So might as well have used loops for that. Well, I'm going to show you what the benefits of recursion is over loops. So I'm going to show you how we did it last time. So it's a tree diagram. So we went through our function x once, so that's it. We're going through it once, and inside we called again, so went through it again, and again, and again. And last time we did like what? I guess, I don't know how I did it, but you can sort of see how we go through it once, twice, 3, 4 times, and 4 times. And it's still going in sort of a linear pattern. Well, using recursion we can go in a non-linear pattern, because with this you might still use loops, and with recursion you can also go in this manner and call x over and over again. So here, when you run x, it'll call x 2 more times. So when you rerun it, it will again call x 2 more times. This is where recursion starts to get very mind-boggling, because this is only twice. If you call x, I don't know, like 3 or 4 times within x, then it'll get extremely complicated very fast. So that's how more complicated recursion process would look like. So let me show you one cool use of this. Alright, let's say we have a method called changeLine. And what it does is it changes the line from a straight line to a line more like that. Alright? So change the line from that to that. Well, this is a fairly simple process. That makes perfect sense. Maybe you don't know how to do this in programming, but if you know a little bit about programming with graphics and drawing lines, then this is a fairly simple process. So now let's move one step ahead, one step further. We start with the triangle. An equilateral triangle. This is an equilateral triangle, but imagine that it is. So we apply this method over to each side of this triangle. So we end up getting a star pattern. So there you go. You get a star pattern like that. We could apply it again. And let's see. You could sort of think of it as the same star. So there you go, there you have the same star as we had up here. So now we're going to apply that to each one of these. I drew it bigger so that I could do this more easily. So I would make that into that, that into that, that into that. So there you go. You can see how the design turns out. So we started with the triangle, and just through 2 iterations, it becomes a much more complicated thing. Now the question becomes, what would it look like if we went through infinite iterations? Well, it will look something like that. So what makes the difference from what we did previously is that you can't draw it in a linear tree diagram. You have to draw it in a more multi-dimensional one. So if I get rid of that, I can show you how that works. So we went through our first iteration, which I guess created the triangle. And then how many times do we have to call this method on triangle? 1, 2, 3 times. So we go 1, 2, 3 times. Okay? And then how many after that? Let's see, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So let me think how that goes. For each one of these we call it 4 times. So 1, 2, 1, 2, 3, 4. And so on, and so on, and so on. And again, you can see this gets very complicated very fast. So this is, these type of patterns are what we call fractals. So you can start with infinite base cases and start with infinite of these types of methods and create so many cool different shapes. If you Google fractal, you'll see all different types of stuff that can be made using this process. Some are even done in 3D, which look even more weird and mind-boggling. So that's one way it can be used. And if you just know a little bit about drawing lines on a 2D surface in Java, you could make a program that does this fairly easily. So, but this is not what I'm going to tell you about today. This is just a graphical representation of what you could do. So today I'm going to tell you how to find numbers in the Fibonacci sequence using recursion. So, the Fibonacci sequence. It starts at f1, and that's equal to 1, and f2 is also equal to 1, and then those are stated for the first two, but then after that, for any number that's not the first second number, you have f sub n is equal to f sub n minus 1 plus f sub n minus 2. So if we were to draw the pattern, we'd have the first one being 1, second one being 1, and the third one would be one of these. It would be solved in this fashion. The nth one is equal to the sum of the previous two. So in this case, previous 2 is 1 plus 1, so third one is equal to 2. The next one is 2 plus 1, is 3. Next one is 3 plus 2, which is equal to 5. Next one is 5 plus 3, equal to 8. 8 plus 5, 13. And 13 plus 8 is 21. And so on and so on. Goes on infinitely. It's quite an interesting sequence. Comes up a lot. I learned how to make a recursive program to find an individual number last semester in my computer science class for MATLAB. And right now I'm in mathematical proofs, and we use this all the time to prove different things about it. There are a lot of patterns that come up with the Fibonacci sequence, such as if you take f sub n divided by f sub n minus 1, it's equal to phi. As n gets bigger and bigger, it gets closer and closer to phi. And phi, I can probably make another video just talking about all the stuff about phi. And when Fibonacci initially started using this, he's not discovered the sequence, he just was the first one to find good uses for it. He used it to talk about population growth and that kind of stuff. So it's pretty neat stuff. So for our program, we're going to have the function fib, and we're going to call the nth one, and we want to give us what the nth one is. So if we take fib 3, it should return 2. And if we take fib 5, it should give us 1, 2, 3, 4, 5, which is 5. And then one more. Fib 8 should give us 1, 2, 3, 4, 5, 6, 7, 8, 21. Okay? So the way I would draw this out using the circles like I did in the last video would be something like this. So I have big circle, and we're going to call this fib with n. Okay? So then I'll just draw this out in 2 ovals like that. We draw out the sum of 2 different sequences. Alright, makes sense. So, and then each of those individual sequences, we'd have the sum of 2 more. So for this one it would be fib n minus 2 plus fib n minus 3. And then for this one, it'll be fib n minus 3 plus fib n minus 4. Alright, so this is the basic pattern. We have fib, which is equal to the previous 2 fibs added together, so fib n minus 1 and fib n minus 2. And then inside those, it'll add the ones of the previous 2. And it can't go in negative numbers, so eventually they'll reach these f sub 1 or f sub 2, and we program it in a way that if it is f sub 1 or f sub 2, it'll give 1. And then you'd have it at the bottom of the sequence where it will have given 1, and then it'll go back up the ladder through all of these, give the answers up until we get the answer for fib n. And that is how we would use recursion for the Fibonacci sequence. And now I'm going to show you exactly how you do that using Java. So today we're going to make a program to predict the Fibonacci sequence, as I said in the introduction. Like last time, we're going to make a recursive program, but this time it's going to branch off into 2 methods rather than 1 every single time. So to start off, we're going to call our method fib, and I'm going to say fib 3 or 4. I'll go 4, which we'll call the 4th Fibonacci number, and this will tell us what the 4th Fibonacci number is. And I'm going to go ahead and print that out so that I can so we can see what's happening. Okay, then we'll go ahead and define our method. Public static int, because we're going to tell it an int because that's what how it can represent our Fibonacci number. And then I'm going to define the parameters, and I'm going to say int n. That's the number we want to find. Okay. About this static, you don't have to know why it's referenced in static context for this one, but it is. But I don't want to take too much time on that because that's one of the more complicated issues. And for the longest time, if I got needs to reference some static error, I would make it static, and if I if I say you can't represent static, I take away static. So I just played it by ear for a long time, and that kind of works. So alright. Fibonacci sequence is defined as the sum of the previous two numbers in the sequence. So we can just go ahead and say fib n minus 1 plus fib n minus 2. That's the answer to this one, right? So I can say, I'm going to make set up a variable int a and s and set equals 0, and then here I'm going to say int a and s is going to be equal to that, and then I'm going to return a and s, and I cannot have the int there because then I'd be redefining it, and that's not allowed. So the whole idea of recursion is that by calling these, we're assuming that they will work and be able to find it at some point. So with that, we need to set a base case where it can be found at some lowest value, because it's going to keep decreasing, as you can see by this. Alright, and so by the rules of the Fibonacci sequence, if n is equal to either 1 or it's equal to 2, then we're going to have a and s be equal to 1. That's the rule of the Fibonacci sequence. The first two are equal to 1, so the first one and the second one will be equal to 1, and otherwise we'll find out what the previous ones were. Okay? Now this one's somewhat more confusing than the last one because I call the method twice in the same method, making it branch out more, making it more mind-boggling. But I would encourage you to just try and look at it and try and think what exactly the code is doing, because being able to fathom it just takes a little bit of time. Alright. So now this is our entire program. It's all done now. So let me go ahead and open this, and I will compile recursion bonus .java, very important, and then I will run it. Java recursion bonus, and it gave us 3, which makes sense. I went ahead and put the first two numbers of the Fibonacci sequence over here, and as you can see, the fourth one is 3. Now let's see, let's try and take it a step further. As if we go to the, let's see, it's 4, 5, 6, 7, 8, she has 21. So let me save it with 21 in there, and compile it again, run it. 21. Now let's just find an arbitrary number. Let's see, what should we do? Let's do 20. I haven't tried this, so there is a possibility that it'll exceed the bounds for int, because Fibonacci sequence gets really big really fast, but I think this one should work out fine. So run it and compile it and run it. There you go. See how big that got? So if we went up to 40, I'm just going to test the limits of how far I can go with this. Let's see how much farther we can get. There you go. And so, yeah, the Fibonacci sequence grows at extremely fast rates. It's exponential, which is a lot of times difficult to, you don't realize that at first because it seems like such a simple sequence at first. And that's for my tutorial. Hope you enjoyed it. Please rate, comment, subscribe, and I'll see you guys next time.